Hello guys, welcome back to my YouTube channel .NET-Dev-Journey with Jacob. And today is the day 2 of my journey to becoming a professional .NET developer. Yesterday, we were able to set up our environment, install the necessary tools needed, and we wrote our first program in .NET. And here, as you can see on my screen, I've commented out some lines of code, which was the code that we wrote yesterday. Yesterday, we also gave a two challenge, two questions. And the first question was, why do we think it is important and necessary to have the void main method? Why is it necessary to have the main method in a .NET program? Here is my thoughts on that. The main method in a .NET program serves as the entry point into the program. Let's use this example. For anyone to gain access into a building, then the valid entry point is through the main door, through the entrance, through the main door, which serves as the entrance into the building. In a building, there are different rooms: the living room, the kitchen, the bedroom, and all kinds of rooms. But to be able to have access into any of these, the first point through which anyone can come in from the outside is through the main door, which is the entrance into the building. Without going through the entrance, then no one can have access to the building. And any other access through which one might want to come into the building from is unauthorized, is illegal. So the only legal access into the building is through the main door at the entrance. And that's what the main method also serves as in any .NET program. It is the main door, the entry point into the program. The second question is, why do we think it is important to have various types of data types, like various data types? Why is data types important? Why do we not just have only string data type? And here is my thoughts on that as well. It is important to have different data types. Number one, for efficiency in operations. So let's assume that if we were to have just a string data type and the computer wants to perform an arithmetic operation, how would the computer be able to do that? It wouldn't even know how to add 25 plus 5. Because if we do that using string, we are going to get 255, which is 255, instead of 30. Because 25 plus 5 is supposed to give us 30. But using a string, it will give us a wrong value, which is going to be 255. And the computer won't be able to perform this operation efficiently without first converting it into a number. So, which is also going to result into um, writing more lines of code for a simple operation. Two, for code simplicity, because it helps us to write just minimum lines of code to achieve the result. So it makes our code cleaner, shorter, and easier to read. Number three is memory management. Using the right data type ensures that the program we write just makes use of enough memory. For example, a bool data type uses just one bit to represent true or false. If everything were a string, for example, true would take much more memory because it is 4 characters instead of the one bit that it was or it's supposed to take. So we can see that it's going to, you know, mismanage our memory. And the fourth one is error prevention. When we make use of data types, it helps the compiler to catch mistakes on time, even before running the program. So, yes, this is why I think data type is important. And it is also necessary to know the range so as to prevent overflow or underflow errors. I hope that is understood. So for today, we'll be looking at conditional statements, loops, and methods. So I start with conditional statements. Conditional statements are statements that helps our program or the computer to decide on what line of execution or what part of execution it is going to take based on a certain condition. So it is a flow, a kind of flow of control that helps the system to decide on which parts to take based on a particular condition. And we have major um, conditional statements. We have the if conditional statement. We also have switch. Switch is a conditional statement. If as well is a conditional statement. So, and I think we have if else as well. The if else, yes, if else, and is it if else or else if? Think else if, and we have the switch. So here we go. This right here is the syntax for writing an if statement. So we say if condition, then do this. If condition, then do this. So here we have the expression. So here we have sorry, it's a executes this block of code if this condition is met. If this condition is true, then execute the block of code in here. And if not, it would not do that. So let's go. I would say int age. And I'll quickly say this. There's a naming convention that is advisable to use when declaring a variable name. So we have the camel case. and we have the Pascal case. So the camel case is always advised to be used for writing variable names, for declaring variable names, while the Pascal case is advised to be used for naming a method. So here we are having a variable name, so I'm using the camel case age. Oh, okay. For those wondering what a camel case is, so this is a camel case. First name. So a camel case means that the first character of the first word will be in small letter, while the preceding words, the first character of the preceding words will be capital letter. So we see first name can be split into first is one word, name is another word. So for first, we can see that I'm using the small letter, the lowercase, while for the name, I'm using the uppercase N here. So that is how to write um, a camel case. And for Pascal case, both will be in upper case, like this. So we'll go back to the Pascal case. So here I say its age is equals to 20. So for the condition, I'm saying if age is less than 18, say console, let's write line, you, I, yes, to be an adult. Yes. So if age is equals to 18, console, you are yet to be an adult. If this is a if condition now, if statement. So here we have the condition. If this condition is true, it's going to execute the block of code in here. And since we know, oh, this condition has to be if age is less than 18, not greater than 18. So we know that anyone who is less than 18 is yet to be an adult. So from 18 upward, the person is an adult. So here, let's run this program and see what the outcome will be. So how do I get here? You can use the control single quotes quotation sign, but you can also come here and click on new terminal. So here, I just have .NET run and let's see what the outcome will be. It's loading. Okay. Why is it not giving the output? Int age is equals to 20 if age is less than 18 console.writeLine. Yes, supposed to run. What's going on? Oh, sorry, I know where the error is coming from. I was supposed to use the else because it's a conditional statement. So it's supposed to either do this or do something else. But because I didn't specify the something else for to do, so that's why we are having that. So you can just say console, it's right line. You- So let's rerun the code and see what happens. You can see the output here, you are an adult because we have 20 and the age is not less than 18. The age is greater than 18. So let's change this to, let's say 17 or 15, and let's rerun the code and see how this works. As you can see here, we have you are yet to be an adult. Oh, sorry. Supposed to be you are yet to be an adult. Yeah. So this is how this work. And I also spoke about if else statement. So we have we have the if else if statement, and this works when we have more than two conditions to test for our computer to decide on, or for our system or application to decide on what line or block of code to execute. So let's also have an example for that. Let's say we have in score as a score of an examination, and we have the score to be 68 here, and we are saying that we want to store the, okay, we don't even need to store the outcome into anything, but let's say we want to know the grade of a particular student based on their score. So we are testing the condition for the score to be able to get our grade. So here we say if score is greater or equal to 70, if score is greater or equal to 70, so we are saying if the score is greater or equal to 70, then we say you have you are excellent. You are excellent. So here we say else if score is greater or equal to 50, then we say you passed. Then we have else. You fail. So here we can see we have more than two conditions to be tested. So right here we use the else if um, statements. We have the if, the else if. So if is usually used for, let's say, one or two conditions max, and for else if conditions that are more than two. So instead of using the if, we'll switch to the else if because we are testing more than two conditions. So let's run this code and let's see what the outcome be. As you can see, here we have you passed. Why? Because it is greater than 50. This right here is the block of code that our program executed. Reason because this condition is met. If we look at it, we say score is greater or equals to 50. So yes, is 68 greater than 60 than 50? Yes, it is. But here we say score greater or equals to 70. Is 68 equal or greater than 70? No. So that is why it satisfies this condition and it executes the line of code in this block here. And here we have you passed. So if we were to change this for 49, which is obviously less than 50, and let's test the code again and see what the output will be. You failed. Why? Because it does not satisfy or meet any of these two conditions. So that is why it is else, which means if it does not satisfy any of these two conditions here, execute this line of code. And we have here, you failed. This is how to use if conditional statement and else if conditional statement. So peradventure, we might also have more than one else if. We can also have another else if here and say if score is greater or equal to 35, and copy this. If score is greater or equals to 35, you failed. Else, you are advised to withdraw. So let's run this block of code again. Let's set this to 34. 34 and test it again. So here you are advised to withdraw. You are advised to withdraw. That's it. Now we move to the switch conditional statements. So here, instead of using this pattern of the if statement, we can also change this to a switch statement. And how do we do that? Let's comment out this. So comment Control K, Control C. So we've commented out this part. So to write the switch statement saying switch score, we have case is greater or equal to 70. I'm not sure, just guessing. Okay, let's look at the control cannot fall out of switch from final case label. Case greater or equals to. Okay, I think I'm right. So we say, we repeat the same thing. Okay, you are excellent. And case greater or equal to 50. Let me just copy this. You passed. Copy all of this. Case 35. You failed. You failed. Then this is going to be default. Default. We have you are advised to withdraw. You are advised to withdraw. So here we have this. So instead of the previous if else if statements we used, we are using switch statements to perform the same operation. So let's save and run this block of code and run the program rather, so that we can see the outcome of it. So the same thing, as we can see here, you are advised to withdraw. You are advised to withdraw. You are advised to withdraw. But we can also do this in a better way. We can make this better. To the advanced way of writing the switch statement. So let's do this. We have string outcome. Okay, let's say string outcome or string results is equals to score switch. So we have greater or equals to 70. We say string, you are excellent. Don't forget for string we wrap it, we put it in double quotes. So it should be comma here. Then for the next condition, which is greater or equals to 50, we have this you you passed. Then for the third condition, greater or equals to 35, we have you failed. Then for the last condition, just have this. That is the default condition. Be advised to withdraw. So here we have it. You can see all the lines of code that we have here and that we previously used in the switch. Everything has been compacted and simplified into this. So finally, we can now say, we can use the shortcut CW. Oh, that's not working. Why is that not working? Yeah, control the right line. Can remove the system. Then we have score. No, we have results rather. Don't forget, result for each condition, this string is assigned to this result. So, and we are printing results, which means we are printing any string that satisfies the condition. And based on this call, what satisfies the condition using this call is the default, which is be advised to withdraw. And this will be saved or assigned to the result here. And once we print out the results, we will see that this is what will be displayed on the screen because this is the string that is saved in the results container or the results variable. So let's run a code and see what our outcome will be. Be advised to withdraw. So we have simplified the process, the switch statement into this, which is the advanced way of doing that. We can shorten to improve the lines of code we have, to shorten it to make it more cleaner. I prefer this method. So now we've learned the switch, we've learned how to use the if statement. So I would like to let's just write a simple application using any of the conditional statements that we spoke about now. But what I would also like us to do is that we will be um we will allow the user to enter the inputs themselves. So we'll be taking inputs from the user. And what we'll be doing is the first program here that we want to write is to test if a person is eligible to vote based on their age. As we all know, that it is only adults from the age of 18 that are allowed to vote. So the first thing we do is we think of how to get the user's age, and after the age has been gotten, then we write a conditional statement to test if the age meets the criteria, the age requirements needed to be an eligible voter. So now we start by declaring a variable name that we will be storing the user's inputs into. So we have int age here, this way. So we can now say prompt the user to give, to enter their age. Kindly enter your age. Then the next thing we do now is to read in the age. So we say age is equals to console dot read line. But we can see we have a squiggly red line here. So let's see, what does this mean? It says cannot implicitly convert type string to int. So which means that at the point where the user is entering their age, the system sees it as a string data type. And don't forget, we have declared that we want to collect that value and store it into age, which is an integer data type. So now this is where the problem is. We want to take a string value and we want to save it or assign it to an integer variable name, to a variable name of an integer data type. I hope you understand what I'm saying now. So, and that is where the error comes from. So to be able to manage this, we need to convert the string to an integer. We need to convert the string to an integer. So one of the ways we can do that is to say int dot pass and then wrap this into a bracket. So we are saying pass the string into an int here. Do we understand that? So pass this into an int, but here is also giving us an information that possible null reference arguments. So here is saying, what if the user does not impute anything? What if the user does not pass anything into it? What if it is just a null value? A null value, an empty value, what happens? So it's just giving us an heads up as regarding what um could happen based on this. So here we have converted it into an integer. I think there's another method as well. Let me say convert dot to int 16 or 32. Okay, let's say to int 32. So I think this does the job well. So I think what this does is probably it converts. Okay, let's do this and see what will happen. Let's test this. Let's just test this. Don't forget, we are learning together. So now let's test the code. So what I want to test is I want to see what the output will be even if the user does not enter any value. So now it's waiting for my input. It says kindly enter your age, but I'm not entering anything. I just want to go with enter. Okay. Here we ran into an error saying the input string, you can see this means empty was not in the correct format. Oh, okay. Okay. So now let's rerun this code. Oh, yeah, that's a mistake. Oh, that's not a mistake, sorry. So let's enter, let's say 40. Okay. We can see it's working now. We have the 40. That's what I wanted to check because using convert.int32, it didn't give us any information for us to know that we are going to run into an error because there was no squiggly line here. That was why I did this to be sure and to see what the output will be. So now that we've done this, we've received the user age. Now let's test for the condition to see if it satisfies the age requirement to vote. So we are using the if statement because we are just having two conditions. If the age satisfies the requirement, do this. If it does not, then do this. So we are saying if age is greater than 18, which is the requirement to vote. Remember in the last one, we did something like this, but here is what I would say. Okay, before I would do that, let's go ahead and say console dot write line. We are saying you are eligible to vote. But if the age is not greater than 18, or it should be greater or equals to, because a person of 18 can also vote, is eligible to vote. So we have this, you are not eligible to vote. So here we have our condition. So if the age is equal or greater than 18, it runs this line of code, it executes this. But if not, it executes this. So this is a program to receive the input, the age from the user, and then test the age to see if it satisfies the condition for voting. And if it does, we have an input, if an output rather. If it doesn't, we also have the appropriate output. So let's run this. Let me save. Let's run this program and then we go from there. So enter your age. I say 17. See, you are not eligible to vote. So let's rerun it again. I enter 18. You are eligible to vote. Then let's test for the last condition if it is greater than 18. So if I am 20, am I eligible to vote? Yes, you are eligible to vote. So our program is running and working fine. So here is what I wanted to mention the other times. Because we have just one line, one statement, or one line of code inside this block, then we can as well remove the curly brackets. Because we also have one line of code here, we can also remove the curly brackets. But if we have more than one line, then we need to put them inside the curly brackets. So let's rerun our code and see if we are going to run into any error because of the removal of the curly brackets. You can see it's working perfectly. It's working perfectly. But if we've got something like this, tests. You can see here we have an error. It's telling us we have an error. Cannot start a statement. So it's telling me here that something is expected. And that's because we have two line of code and they are not wrapped in a curly bracket. So as soon as I put the curly bracket, you see that the error disappears. But if we have just one line of code, we are not going to have any error. So you can see everything is fine. So that's that about that. And most times it is suitable to use the switch statement instead of using multiple if statements. So we can just switch to the switch statements, which helps our code to look simpler, neater, and easy to understand with just a few lines of code. So with that being said, we are going to be moving up onto the loop. So loop, what does loop means? Loop simply means repetition. Repeating a particular action until a particular condition is met or satisfied. So if the condition is not satisfied or met, it keeps running. It keeps doing the same thing over and over and over again. So what are the types of loop statements we have? We have the do while statements. We have the while statement. Then for we also have the for statement and the for each statement. But these two are basically used for iteration, like iterating over a collection or over a number of elements or items in in a particular collection or in an array. So yeah, that is what the for and the for each statement is basically used for, but it's also, categorized as a loop statement. So here we are going to look at each one of these statements and how to execute them. So here I'm going to start with the while statement. So let's declare integer mm, row. So we are saying we want to have 5 lines or rows, and then we say we have row equal to 5, and we are saying while row oh no, let's start from 1. We are saying row is equals to 1, but we want to do something until we have like 5 rows. We want to print something 5 times in different rows or different lines. Okay, let me use line instead of rows. So while line is less than 5, so this is the condition. We say then console dot write line. Let me use concatenation here, or interpolation rather. We have this is line line. This is line line. So what this means, what the statement means is that the line is starting from 1. We have assigned 1 into line. So here line is 1. So we look at it. Is line less than 5? Yes. If line is less than 5, then print out this. This is line. And don't forget, line is 1 here. So it's going to say this is line 1. After that, we increase the line here. We increment it by 1. So line plus plus. We can as well say line plus equals 1, which is the same thing as line plus plus. So let's just go with line plus plus, which is simpler and easier. So here what this does is, after I print the first one, which is line, this is line 1, then it adds 1 to this line and updates the line, then line becomes 2. Then it tests again. Is 2 less than 5? Yes. Then we have this line, this is line 2. Increment again by 1, it turns to 3. That's what it does until this becomes 5. Then it says, is 5 less than 5? No. Once that is met, that's it. And it prints this. So let's do this. This should be less than 6 because we want to have it 5 times. So I will know 5 is less than 6, so it stops at 5. At the sixth iteration, it stops. So let's run this. So here we have it. This is line 1, this is line 2, this is line 3, this is line 4, this is line 5, just like I explained earlier. So this is how to write a while loop statement. And now we move to the do while loop statement. So let me comment this out. Then underneath it, we go with do while. I know somebody might be thinking we have while loop, we are going with do while. Why? What's the difference between while and do while? That is a challenge for you. What's the difference between while loop and do while? And when is it appropriate to use any of these two, either while loop or do while loop? When is it appropriate to use them? You can put that in the comment section below. Let me know your thoughts on why you think it is important, or when you think it is important to use while loop and do while loop. That's the challenge. Go into the comment section. Let me know your thoughts. Give your answer there. And in the next video, I will be giving my own answer, what I think, and when it is important to select either one of the two. So we moved down to the do while loop, and here's the do while syntax. So we say do this while this condition. I hope you understand this now. Do a particular thing, then test for this condition, and if the condition is satisfied, break out. If the condition is not met, keep doing what you are doing. That's just what this means. So now, how do we use the do while condition or do while statement? Here we have an example we used, which is this. We can use the same example right here, but okay, I think I'm going to have to answer the question I asked earlier because that will help this make sense to us better. But before I do that, let's go again. We have int line above here. So I'm bringing the same line of code in here. And then I test for the condition. while line is less than 6, which is the same thing with this one, but there is a simple difference in this, which we are going to look at. Okay, this is what we'll be looking at now. Let's run the code and see what happens. You can see we have the same output 1 to 5, right? But now let me explain the difference between these two. In the while loop we use here, you can see that the condition is tested first before the block of code is then executed, which means even from the first um, execution, from the first conditional validation, or from the first testing of the condition, from the first line, even before the statement is being executed, if this condition is not satisfied, if this condition is not met, then this block of code will not be executed. So it tests for the condition first before executing the block of code. But for the do while statement, it executes the block of code at least once before this condition is tested. What do I mean? Now let's change this. Let's say if one if line is less than 1, if line is less than 1, and looking at it here, we said line is equals to 1, and here we are saying line less than 1. So but it's still going to execute this code regardless, because we know 1 is not less than 1, so it shouldn't run. But it's going to still run this block of code regardless of this condition. And now let's run the code so that you can understand what I mean. You can see this is line 1. It still ran this code, this block of code once, but we can see it did not continue because it was after it tested for this, it was after it ran this line of code that it now tested for this condition. But now let's comment out this and do the same thing with the while loop and see what happens. So we are saying, so to uncomment this, we use Control K, Control U. So now we are saying if line is less than 1, which means if 1 is less than 1, sorry, let me come again. While line is less than 1, which means while 1 is less than 1, do this. If not, don't do it. So we are saying while 1 is less than 1, is 1 less than 1? No. So here is testing for the condition first before going into the block of code to execute the lines of code in there. So let's run this and see what will happen. We can see that I did not run the code because this condition is false. this condition is false, so it didn't run the code. But here, it ran the code regardless. Let me comment this out. It ran the code regardless with the do while loop. Let me run this again. It ran the code at least once before it tested for the condition. So that's just the major difference between the while and do while loop. So the while loop is used if you want the condition to be tested before executing the lines of code or before executing the block of code. So, but for the do while, you need to use the do while loop if you want the block of code to be executed at least once, regardless of the condition, regardless of whether it satisfies the condition or not. So I'll give you an instance of how to use a do while loop. And let me paint an analogy, a non-technical analogy. So for a while loop, let's say you own a car and your car is parked in your garage. You're planning for a journey and you are driving. So what the law requires is that before you start your car or drive your car, you have to inspect the car to see that it is in a good condition for the road. It is roadworthy. You check the tires, you check the indicators, you check the lights, you check the brake to be sure that it is firm. You check the tires to see that it is not budgy, it is not bad. The lines, the 3 out of 4 lines of it um, matches with the valid tread depth. Those are the things you check. If it is a car that uses petrol or fuel or diesel, you check to see that it has enough fuel in it for the journey. If whatever you need to check in the engine to see that the car is fit. Another analogy before you then take the car out on the road. So the conditions are first checked to see if they are all met and satisfied before you take the car on the road. You don't take the car on the road before checking. You check before taking the car on the road. And this means that if any of this condition is not satisfied, then the car is not roadworthy and you will not be taking the car on the road. So on a farmland as well, that the farmer needs a tractor to work on. Whoever will be using the tractor needs to first check if it has fuel in it to power the tractor before they can use the tractor. Without the fuel in the tractor is not going to work. That is an example of the while loop. And now, to explain this in a technical way, we can say that if a file does not exist, then nothing should be done. For example, we want to save a data into a particular file. So the condition is we test if the file exists. If file exists, then go ahead with saving the data or record into the file. If the file does not exist, then there is nothing to do because the file does not exist. So the condition test for If the file exists, then save this record or the data into the file. Now we move down to do while loop. How and when can we use a do while loop? For instance, in the last program we wrote a program that takes in inputs from a user, tests the input against a particular condition to see if the condition is met, then performs a particular operation or executes a block of code. So what the program does was it reads the age imputed by the user, tests the age to see if it satisfies the requirement for voting, and then performs a particular operation based on that. So now we can use do while loop in that sense that we can collect the input from a user before testing if that input satisfies a particular condition. Now let me make it more simpler. Remember when we took the input from the user, we converted the input to an integer value from a string. So we can make use of a do while loop to collect the user inputs and then convert this input into an integer and then see if the input is convertible to an integer. If it is not, then it raises an error message. But before this can be done, at least we need the user to enter the input at least once, because without the input, then there is nothing to be converted to an integer value. There is nothing to read in and be converted. So there is need for the user to enter their input, their age at least once. Then based on that, the system can then convert the input, read the input, then convert it to an integer. Without any input, then there's no conversion. So that is where do while comes in. I hope we get that. Now I'm going to write a code to show us an example of the do while. I've explained while, the while loop. I believe we understand that better. But in the context of the explanation I use for the do while loop, let me quickly write um, a code, a program to explain that better. So the next thing is to read the inputs. But here is what we want to do. So we want to use a do while loop here. So, and I also want to say bool is valid. Okay, I can say bool is valid is equals to false. So here I can say console dot read line. This is going to be Mhm. Okay, is valid is equals to try pass. Sorry, it's that's try pass console dot read line out stage. And here I say if let's let me use valid instead of is valid. So if not valid, then I can say console.write valid entry enter your age. So now I say while not valid. So this is what we are doing. So this is unnecessary. Yes. And then here I can now do whatever I want to test, like if age is greater or equal to 18, congratulations, you are eligible to vote. Else, try again when you are 18. So let's run this code and see. So here, before we run it, you can see what I did was first I prompted the user to enter their age, and I declared a variable name here, age, to take in the age, which will be of integer value. Then I declared here valid, which is a Boolean um, data type, and which is just going to be maybe true or false. So what I did here was I I read the input of the the user. I tried to convert it to integer and I pass it out as age into the age. So, and here is a Boolean value. So this is a Boolean expression. So it means that if this is successful, then the value will be true. But if this is not successful, then value will be false. And then I said, if not valid, which it means if it is not true, if this condition is not satisfied, then prompt to the user that they have entered an invalid entry, kindly enter your age. So this helps to undo if the user is inputting an alphabet instead of a number, or if they are not even, you know, putting or um, if they are not typing anything at all, if it is just empty. So it helps to do that. So it takes in at least the user needs to supply their age at least once, and it runs this code at least once before testing for this. So now let's run the code and see what happens. So let me enter an alphabet and see what happens. You can see invalid entry, enter your age. So it keeps doing this block of code here until this becomes true. So if this is not valid, it keeps repeating this until this becomes true. So enter your age and okay, let me say 45. And now you can see out of the block of code because this condition is not true. It has not been met. This here is saying if it is false, and we can see that 45 is an integer that is convertible. 45 is an integer value, and which makes this true. But here the condition is saying if it is false, but here we have true. So it cannot repeat this block of code anymore. So that's why it came out of that block of code and it proceeded to executing this conditional statement here. And 48 is, greater than 18. And here it executes this line of code. Congratulations, you are eligible to vote. I hope we have been able to learn something today. And finally, quickly, I know I've stretched us a little, but quickly, let's quickly look at method. Method. So we are going to be looking at method now, and here. So what is a method, and or should I proceed to method or should we do? Okay, let's proceed to method. But before I proceed to method, I will quickly write a program that just adds two number together. So, oh, sorry, I've not spoken about the for loop and for each loop. Yes. How do I go about this? Okay. There is something called collection. There is something called collection. So, collection is just the grouping of related data, the grouping of related elements. And array is a collection. We have lists. List is also a collection with array playing a vital role at the background. So list is just like is an array at the background, an array that has been modified, redefined, but at the background. So here we are going to be looking at um, an array, and then we are going to be looping over an array using for loop and for each loop. And also we are going to look at another dimension of using the for loop as well. So let me start with the for loop. I hope we understand the while and the do while loop properly now. So we are going to the for loop, and we'll explain that very sharply, and I'll keep it short this time around. So yes, so um a simple example of a for loop is this. So for int high is equals to 1, then we can say I is okay. I want to use the same example I used the last time for a while loop so that we can get it well. Then we have line less than 6. Then we have line plus plus. We can go back to the video so that to the previous loops that I spoke about, so that we can see the distinct differences between them, so that we can see how they are executed, how they are written, and how they can be used. So here, console.writeLine. So I'm using the same thing I used with the while loop, saying this is line. So this is just going to do the same thing that the while loop did. So we can now choose which option we want to go for, which suits us the most, but then we need to know how to apply them as well and when to make use of them. So let's quickly execute this program and see the output. So here we have it. This is line 1 down, so this is line 5. This is line 1 down to line 5. So here, I'm looking at what we can do right here. I'm looking at the example that we can use. Okay. Like I said, this is majorly used when we want to iterate over a collection, a list of items. For example, let's say we have uh, different products in our carts, and we want to iterate over them to list them out. So we can use for um, for loop or for each loop. So let me use another example. So let's say we have a string of fruits, an array of fruits rather. Don't forget we are learning together. So we have array of fruits, let's say orange, we have banana, not sure if I got the spelling right. We have apple, we have mango. What else can we have? We have pear. What other fruits? Uh, okay, we have pawpaw. Then we have grape. So let's say this is what we have in our array. So we have array of fruits. So and in our array we have this all these fruits um in it. So if we want to iterate over this array to say what we have, for example, let's say okay, we want to say what we have in our basket. So let's assume that this fruits is a basket of fruits, and we don't know all the things that are in our basket. So how do we do this? And yes, I will say this again, for loop can be used when the length is known. And how can we know the length, the size of our collection, or the size of our array, or the size of our basket? The size is just telling us the number of items in it, and the we can easily get the number of item in any collection. How to do this is in C sharp. C sharp has an inbuilt method, a way of getting the length the of our collection. So I think list uses count, then array uses length. So here is what we do. We can say for int f equals 0, because every array is indexed from 0. This is not the best example anyways, but I'm just trying to let you see how to iterate over. For each would have been the best here, but we can also use for. So let's say then f is less than fruits dot length. Then we say iterate f plus plus. So I'm using f as, okay, let's say, let me give it let me do my gets in the spelling. So let's say this is fruits, not fruits. So we are saying fruits is equals to 0. That's from index 0. Fruits is uh fruits is less than fruit dot length, then fruits plus plus. fruits plus plus. But another thing we can also do, we can say I as index. So we are looking at the index. So we are saying now what are we inputting out? Ooh, excuse me, guys. Oh, so what are we inputting out of this? We can just say, okay, print uh, contains basket contains. So I'm supposed to get basket contains orange, basket contains banana, basket contains apple. So let's see if that will work. Oh, we only printed out uh the indexes. So yes, to print out the item itself that in that index. From here we can let's count 0, 1, 2, 3, 4, 5, 6. This is 7. 1, 2, 3, 4, 5, 6, 7. We can see we have 7 in here, but it's indexing it from 0 to 6. So 0 inclusive, making it 7 items. So to print out the items itself, what we do is we say fruits. We reference the basket containing the items, which is the fruits. Then we put this in a bracket like this. So we are saying print the um, item containing index this of fruits. Print the item in index I of array fruits. So let's rerun this program and see what we're going to have now. So here we go. We can see basket contains orange, basket contains banana, basket contains apple, basket contains mango, basket contains pear, pawpaw, grape. And here we can also achieve the same results by doing for each fruits, for each, sorry, string fruits in fruits. This is the simplest way of doing this, but there are also distinct conditions, some distinct conditions for which they can be used, either the for or the for each can be used as well. So if we are iterating over an array or over a nested array, then for loop is the best to use. But if it is just a single array, then we can use a single collection. We can use a for each statement. So here we just have fruits. And let's run the program and see if we have the same result or not. There we have it. One thing I would also like to mention, it just came to mind now, to make use of the do while loop. I mentioned earlier that do while loop takes or performs or executes the block of code at least once before the condition is tested to see if it is satisfied or not. So in a case whereby you want your menu to be displayed, so the menu will be displayed at least once before the user can then click on exit to exit the application. So let's say we write a food ordering application or a simple ATM application. We know the first thing or whatever application that we want to write on the console, we know we can display a menu on the screen for the user to choose which option of the operation they would like to perform. So in an instance like that, the menu needs to be displayed for the user at least once to enable them pick their option, and they might likely pick or click on exit, but the menu has been displayed at least once, because without the menu the user cannot do anything. So the menu needs to be displayed once. So we can also use do while statements for in a condition like that. So I hope we get it. So I'm giving us this challenge as I bring this um, video to a close. We have learned about the loops. So I want us to, using this knowledge, to write applications, to write a program, you know, using any of these conditional statements or loop that we have mentioned here. Just, practice, write a program using any of these things that has been learned, and that's how we become better. I will do the same, and tomorrow we'll be discussing on what we have learned again. And tomorrow will be the third day. But quickly before I go, I want to speak on what a method is. So quickly, uh, method. What is a method, and how can we make use of a method? So I would say a method is a named block of code that performs a particular task, and it helps us to take care of repetitions in our code or in our program. So instead of writing the same code over and over and over again, we can just, write a method, and then whenever we need to perform the same operation, so instead of writing repeated codes all the time, we just call that method again. So we can write our code once and reuse it So it helps to um, encourage reusability. It enhances reusability. It helps us to reduce unnecessary repetition, and it makes our code even more cleaner and simpler. So don't forget, I said a method is a block of code that helps to perform a specific task. For example, we can have a block of code that performs addition operation. We can have a block of code that reads in inputs. For instance, we use the do while loop mentioned earlier to read input and you know convert the input into an integer value. We can do that in a method. We can write that as a method so that we won't have to keep rewriting the do while loop for instance, let's say I'm to take the age of two persons, and I've written the do while loop to test for the first input, which means I'm going to be repeating the do while loop again, the same thing to test for the second input, which is not too uh, which is not too good. So I would write a method here to show us something. So a method, then don't forget, remember I mentioned naming convention where I mentioned about the Pascal case and the camel case. And I said the Pascal case is necessarily used or is conventionally used, let me put it that way, to declare variables, to name variables, while the camel case is the camel case is used conventionally for naming variables, while the Pascal case is used conventionally for naming methods or classes. So now, let's say I want to have a method that, okay, before I mention that, a method can either have a return value, a return type, or can either be a void type. And okay, let me do this. Let's say that's a void addition a int a comma int b. Can have something like this. So we can have something like this. Sum is equal to a plus b. So here, addition is a method which has a void return type. A void return type means it is not returning any value. It's not returning anything. But if it has a return type, we can also have something like this. And we'll say A plus B. The reason why we are having this, if we look here, is a private member program is already defines a member called addition, which is because we already have this. So, okay, let me just add one more parameter here. So, this is called method overloading, but we'll be coming to that later, later on. So here, uh, we have a return type of integer here, and for any method that has a return type, we must use this keyword return. It must return something. But for void, you can see there is no return here. But for any method that has a return type, maybe of if it is of string, then here it has to be string. But here we are returning an integer value. That's why we are having int here to specify that what we are returning is an integer value. So I hope we get my point. So now, how do we make use of this? We can just simply call this here in the program. Static here means that it is static to this class here, static to this place. So which means if we want to use this, we have to call for the class, then we say dot, but that's not where we are going. Let's just focus on the method. So here we are saying, for instance, we want to add two numbers. We are saying int a is equals to 5. Let me see if this will work. Okay. So now I can say addition A, comma B. So now I declared a variable of integer here, and I'm passing those variables here. Don't forget, these are parameters, int A, int B. Parameters simply refers to a reference to the actual argument that will be supplied into the method when it is now being used. Now, this is just like um, how do I put it? Yeah, this is just like um, a how do what's the right word to use? Okay, we know that method is a block of code, but this block of code has not been implemented. It is like an operation that is yet to be performed, that is yet to be implemented. So whatever we have here is referred to as parameter. But right here we have argument. The difference between what we have here, the argument and the parameter, is that here this method is now being implemented, executed. It's being executed, yes. The right word is it is being executed. Here it is not being executed, but here it is executed. And at the point of execution, what we pass into it is no longer a parameter, it is an argument. But it's referred to here as a parameter because it references the arguments that will be passed in. The arguments are the value themselves, although you can pass in a reference type as well to a method, but that's not what we are doing here. We are passing the values directly, and these are the arguments here, A and B, which is this variable A and the variable B right here. So now let's run this code and see what we have. Don't forget, we are learning together. So we can see that 5 and 7 is what we got here. But it should not be 5 and 7. That means it is seeing it as a string, not as an integer. Not as an integer. So let's do something. Let me put this into a bracket and let's run it again. So now we have 12. 5 plus 7, 12. Before it was seeing it as a continuation of this string, and that was why we have 57. But putting this in the brackets, that is separating this from this, and this sign as a concatenation. So it means perform this operation, then concatenate it with this. So and here we have sum is equals to 12. But mind you, not all methods return, or not all methods have arguments. Let me give you an instance. What instance can I use? Okay, I can just say addition, and I can pass my values directly into this place. And then I just call addition right in here. Let me comment out this line. And here we can see 14. So here we are not passing in any arguments. This one has no parameter, and that's it. So here we can also test for this addition here with 3 arguments. So, or with 3 parameters. Then we say C is equals to 10. And that's all. So here we can just say A, comma B, comma C. So we pass in the arguments into it. So you can see that we have no error. Here it has made this one come alive. Here this has been pushed backward because it is unused. Before now, this was the one that was unused. Now this is the one that is unused. So let's see. And don't forget, here we are dealing with a return type. So what we do here is we say int sum is equals to this. Then we can now print this out here and say console write line sum plus sum. So we want to do the addition of three numbers. Then we call this method to perform it. And because it's a return type, is a method of integer return type, we are returning the result of this method, of this operation here, into the sum variable, and we are printing it out here. So let's do that and see what the output is going to be. So we have 22. So let's calculate together. 5 plus 7, 12, 12 plus 10, 22. And we can see sum is equal to 22. So here we have the difference between the void and the method with a return type and the method that does not have a return type. So I just quickly wanted to touch on the method today. From tomorrow, which is going to be the day 3 of our journey, of my journey and your journey to becoming a professional .NET developer. We'll look into methods better, and we'll even write some programs or few programs using the methods, using the loops that we've learned, using the conditional statements. Yeah, we've done a bit of that, but we'll just look into writing a more simple application that, a complete simple application using all that we have learned and all we'll still be learning tomorrow. Thank you for staying with me. Please, I would like you to comment your thoughts on this video. You can ask your questions, give your observations, and even recommendations or more explanations as it were into the comment section below. Please kindly subscribe and like this video so that you can keep getting updates as I make the daily video of my journey to becoming a .NET programmer so that we can learn together and we can go on this journey together. Thank you very much. See you tomorrow, day 3 of my journey to becoming a professional .NET developer. Don't miss it. Bye.